Okay, everyone, welcome to our second meeting for CCNA Security for our instructor training classes for spring 2018. A couple things I want to do. First off, I want to remind you again on the labs, do not take these labs like you would a normal CCNA lab. These labs are huge. You can see this is a 38-page lab, so this is not a lab. And there's only one lab for Chapter 2, so it's not like you're going to have to do 10 labs for Chapter 2, but when you do your labs, make sure you go ahead and do a 4-hour reservation as long as you can possibly reserve the system, because if you don't, you will run out of time. Again, the other thing is I would probably build me a little basic config for each one of the routers that you can drop in via text, just a text editor. So, you know, see here, basic device settings, cable the network, which obviously you don't have to do. Configure basic IPs, configure OSPF, all those things. And then those are the basics that are going to be done in almost every single lab. And so you'll be able to drop that in each time. And they walk you through how to do it, giving you the basic information. You'll notice that they don't put usernames and passwords in the basic configs, because in most of them you will be going through and doing it through, especially in this one, you're actually going through and setting up all the basic management plane items that we're going to talk about today in class. So be aware of that. Just give yourself some time. Don't try to do it in an hour, because it will be very difficult. Now, if you do build your own equipment in your lab, which some of you have talked about doing, if you do build this lab in your own lab, a couple items I will remind you of. One is make sure you've got the K9 image. Make sure that you've got a K9 image to be able to support some of the security commands. Also, make sure it's, like today we're going to talk about Scrypt, and Scrypt requires version 15.3 or higher. So if you have routers in your environment and they do not have the iOS version that you need for this particular class, they will work fine for a normal CCNA lab, but they may not work for the CCNA security because they don't have the K9 image or the version high enough to support some of the features that have just come out. The other thing I will show here, what is it? I'm drawing a blank here. Dang it. Been hit by a truck, that's my excuse. I'm trying to show the features that are. Oh man, that's bad when you draw a complete blank. But just make sure that the K9 image is turned on, and I'll send out information on how to do that if you haven't enabled those feature sets. It's early in the morning, and I have not had enough coffee.
I feel your pain.
Ooh, yeah, I'm looking here. I'm consulting the Holy Google. So, and if anybody wants to throw in the exactly how to do this, so I don't have to look like a doofus looking at the feature sets. So, just trying to see what's enabled and what's activated, the licensing. And that's what it is, show license. There are days, folks, there are days. And you see the feature sets that are turned on. So in this case, I've got base K9, I've got security K9 turned on. And it's right to use, evaluate right to use. So those are the show license feature. I believe there it is. There's one. But so I got security K9 turned on. And so that's what you have to have turned on in order for your for the CCNA security labs to work. So, but just again, a quick warning about that. Now let's talk about Chapter 2. In Chapter 1, we talked a little bit about. Can anybody remember the 3 parts of a router we need to secure? there were 3 different planes we needed to secure in order to secure a router. Anybody remember any of them?
Control plane.
One is the control plane, definitely. Another one? So the control plane.
Data and management.
Correct. Data and management plane. So those are the 3. I just accidentally started my MakerBot desktop, but it was the control plane. It was the management plane, and the data plane. We're going to talk a little bit about all 3 of those in the chapter today. I'm not going to have time to get through probably about half of this chapter because this is a huge chapter in our lecture, but the big thing we're going to focus on today is the management plane, and this is really an extension of some of the things we've done in CCNA, but now adding in features that were there all along that we just didn't know about. And some of them we do know about now because we've added them to it. But here's an idea of different types of ways of doing edge router security. You all probably have heard of a screening router. So out here you've got a router that does just basic packet filtering. Then you have your firewall. Then you have your internal router. Many people today just have a firewall on the outside and don't have this screening router just because of cost of having 2 routers. But this is what would consider to be the most secure versus a single router approach. You know, a single router approach, you've got to have a router that's also has firewall feature sets, which is one of the things that we kind of, this CCNA security, remember, this class looks at 2 different ways of doing security on a network. One is doing security primarily with a Cisco router as the edge device. It then looks at how you can build this setup where you've got a Cisco router that's a screening router with ACLs, and ASA that we'll talk a great deal about in Chapter 10 and teach you how to configure in Chapter 10. And hopefully by that point I will actually have, we're going to jump through some hoops, but I've got one pod that's got a 5506 on it too, and I'll teach you how to boot that 5506 using our current NetLab system and actually do the 5506 labs, because the 5505s and the 5506 ASAs are very different beasts in terms of the way you configure them. But we're going to learn how to configure the ASA firewall here, and then inside you'll just have your normal router that you have for your internal routing. Now, real world, many people are going to a setup to where they use Cisco routers and a different vendor's firewalls. We are a Palo Alto Network Academy, so our Palo Alto Cybersecurity Academy is what it's called now. So we teach Palo Alto firewalls. Some people use Checkpoint. Palo Alto is having a lot of success because they're an American-based company versus something like Checkpoint, which is Israeli and cannot be used by federal government agencies. So, and some people are going that route for a couple of reasons. One, to be quite honest, Palo Alto firewalls kind of jumped ahead of Cisco ASAs in technology. And 2, it's that entire, they call it security onion or artichoke idea, different vendors to make sure someone has to be able to work on 2 different systems to break into your network. Plus, a single vulnerability that affects one vendor may not affect the other vendor depending on how it is implemented. So, and then here's our DMZ, which most of us do. We have a DMZ off of our firewall to allow for anything that needs to be accessed from the internet to have a hole poked into the firewall so you can come into the DMZ. So that's all pretty much Security Plus stuff there. So how are we going to secure administrative access to the management plane? Well, we're going to look at a bunch of different ways to do this. One is restrict your device accessibility, so when you can get into it, how you can get into it. Log access, authenticate access, authorize actions, and that where you're going to move different commands to different levels so that there's not, you know, right now all you really know about is privileged exec mode and user exec mode. So either level 1 access or level 15 access. So either look and do nothing and do everything. We're going to learn here in just a minute how to move things around to have different levels. So real quick, this If I'm connecting to the console, is this in-band or out-of-band management? In-band or out-of-band management?
Or did you say you're using the console cable?
Console cable, yep. Right.
Out of band.
Exactly. This is out of band. In other words, I'm not going over the network. This is, I go into the server room or into the area where the router is, and I plug a cable into the console port. You'll be amazed the number of people who don't secure access to their physical router. I tell people all the time, the easiest denial of service attack is to steal all the power cables out of a server room. Hey, why do I want power cables? They got copper in them. So I'm going to steal them and sell the copper that's in them. So, you know, that's one thing we'll talk a little bit about. Now, if I'm coming across SSH or if I'm coming across Telnet, which you should never do, then that would be in-band management. And that is coming across the network itself. All right. This would actually be considered, I would consider it out of band because you're coming across this modem to the auxiliary port. The auxiliary port needs to be set into transport input none to not allow people to get into the auxiliary port. And here's one thing we haven't talked a great deal about, but you do a little bit in the routing switching essentials classes about setting up a management VLAN, but you really do need a management LAN. That the only thing that's on that, the only traffic on the management LAN is the traffic to control your networking devices. So you don't have any data traffic moving across that. I'm not going to spend much time on strong passwords, you know, uppercase, lowercase. I will tell you, here's one thing that's a little bit different about Cisco devices. You can have a space in the password on Cisco devices. In fact, most of you have been teaching Cisco long enough. One of the things I always try when I can't get into a student's router with a password is I will always put in our default password with a space, because many times students accidentally put a space at the end. Spaces can be used. They're difficult unless you really know where they're at. You just have to be careful when you're making the password that you don't mess it up. So what can we do to increase access security? One thing is we can change the min length on the passwords. We can encrypt the local passwords in the running config and startup config with a very weak form of encryption. By default, the V2I lines and consoles will log you out after 10 minutes, but if you wish to change that, you can use this exec timeout 330, which is 3 minutes, 30 seconds, so you can change it to something that works with your company policy. Again, I won't spend a lot of time there because you've already seen a little bit of that in previous classes. This is new. This is something that's introduced again after Cisco iOS 15.3. The enable secret passwords have used MD5 hashing up to this point, and will use MD5 hashing if you just type enable secret class or enable secret whatever. It uses MD5. If you want to use, and you should use, a higher level of encryption, so you can use type 8 and type 9, which one is PBKDF and the other is SCrypt. SCrypt is basically using SHA. Both of them use SHA encryption, but type 9 is slightly stronger than type 8, so that's what we're going to use in this class. To do this, it's a little bit different. You can't do enable secret 9 and then put in the password, because if you do this, it's asking for the already hashed password. But you can do it like this. You can go enable algorithm type, and you tell it which one you want, okay? And that SHA-256 is type 8, which is the password-based key derivation function 2 with SHA. If you're ever at a dinner party and someone asks. But we use SCrypt type 9, do SCrypt secret, and then the unencrypted password, and then it will be encrypted. So if you do enable algorithm type SCrypt secret this, it will then put it into the running, and once you save it to the startup config and the startup config, using an scrypt hashing algorithm. So this is new, again, after iOS 15.3.3M, and it does have to have a K9 image, but from here on out, pretty much that's what you should be using. You can even use it not just for enable secret, you can also use it when you create usernames. So we used to do username Bob secret whatever, and that was an MD5 hash. Now we can say username Bob algorithm type scrypt secret Cisco, and then put in your unencrypted password, and then that will then be encrypted. Okay. You also can set privilege level 15, which you've done with this secret. That's what that does. It gives them the privilege level of 15. So any questions on using scrypt versus our typical MD5 algorithm?
Nope.
All right. Securing line access. This is something that we have talked a little bit about, but inside of a router, you do have a local database. We've done this with SSH already and coming in on the V2I lines. We have not, however, really used it for the console line. So if you do username Bob or username admin, algorithm type scrypt, secret, whatever, and you do linecon 0 login local, this will force you to have to log in using a username that has been created on the local database. Now, in small environments, you could have usernames for multiple users, so you could keep up with who's logged in when. On bigger networks, we'll talk a little bit later about TACUS and Radius, about actually going to a TACUS or Radius server and authenticating out to Active Directory or something of that nature, and tracking who's on the device, who's actually authenticated, and what they're authorized to do. But this allows you to apply the same type of login with usernames that we've been using on SSH to the console and the V2I line and the auxiliary line. Again, no big deal there. This is pretty cool though. This is something that for a while was pretty, well, first banner message of the day, that's no big deal, was a little bit controversial. And that is simply because for a while they only had the first command, login block for X number of seconds, attempts, tries within seconds. In other words, you could say block logins for 120 seconds if there are 5 invalid login attempts within 30 seconds. Now, what would happen then is it would completely block anybody logging in to the router. Well, there's a lot of debate about locking out accounts after unsuccessful login attempts, because one of the things you have to think about, just like in a Windows environment, if you set it to where you have 5 invalid login attempts and I lock your account until an administrator locks you in or unlocks your account, I can actually perform a denial of service attack against your network by creating a script in PowerShell that tries all your usernames with bad passwords, and then you would automatically, I could lock out everybody in the domain. So that's one thing. There's some debate in the cybersecurity community about this. However, Cisco gets around that problem by this second item, which is login quiet mode. Now, what happens is if you violate this first set of parameters, okay, so someone tries to log in 5 times within 10 seconds, and it's going to hold it for 120 seconds before you can log in again. The router then goes into what's called quiet mode. Well, during quiet mode, you can actually set an ACL and define a management range or a management device that can log in even while logins are being blocked, so during that quiet mode. By default, as far as when you try to log in on a Cisco device, the delay is 1 second, so if you miss it and hit enter, it will automatically just pop back up in 1 second. You can change that if you want to, so makes it slower for password crackers or dictionary attacks. And then log on, success log, this would log it into whatever you're logging to, be it your Syslog server or whatever, and log on failure, those will do the same. So if we say login block for 15 seconds, any attempt within any 5 attempts within 60 seconds. Okay. And then we do, and that, by the way, I would probably block longer than 15, but then you do an access list that says permit admin and put these 2 admin hosts and then say login quiet mode access class permit admin, delay 10 seconds, login on success log, on failure log. This would allow you to cause logins to be blocked if someone violates these rules while still being able to log in with your management machines on the router. So again, just adding in additional management plane, okay, security. Normal mode is watch mode. This is when it's actually looking for these particular parameters. Quiet mode is when it has failed these parameters and is no longer allowing any connections via Telnet, SSH, HTTP, or any logins at all, and unless you've got that access class set for quiet mode. So again, if not configured, all login requests will be denied during quiet mode. So be aware, you need to set this if you're going to set the other. And here we just show it's logging, show login, and it's login. When you do the invalid, it's going to go out to your SSH and do show login. It's actually going to do it here. In this case, it's just it's not sending it out to a Syslog server. It's just logging it locally. Okay. I'm not going to spend a lot of time on SSH. You should already know how to do this. The quick thing I am going to say is notice how they're using this scrypt now for our username. So we got username Bob, algorithm type scrypt, secret, and that we use the type 9 encryption. The other thing I will tell you is be aware that, again, you have to set your domain name first and before you can generate your crypto keys. The only other thing I will say is that for some reason you ever need to remove your keys, the command is crypto key zeroize RSA. That will remove any public-private key pairs that you've generated for SSH and will allow you to actually create a new set. So for instance, if your domain name changes for some reason, you see the key name is r1.span.com, so it uses that as part of the generation. So some of the things you can do, we've already talked about this a lot. SSH timeout, 60 seconds retries. We'll let you retry it to 2 times before it kicks you out. By default, it's 3 times. You know, when you try to log in with PuTTY and you mess up the password 3 times, it kicks off totally. Hey, Sandella, how are you? So connecting, here's one thing that's a little weird. People don't know that you can actually SSH from a router to another router. Command is SSH-L, and that's L for who you're logging in as. In this case, the username is Bob. Here's the target. If SSH is enabled, it will then prompt you for the password, and you will be able to connect from R2 over to R1 using SSH without having a client. So this lets you pop around inside your network using SSH and do it securely. Of course, you can use PuTTY or Super PuTTY or whatever. Now, this is where things get really interesting. To this point, you've really only known about user exec and privilege exec modes. And there is another mode, mode 0, which basically has no access, but has very little access, just a couple little commands. But you've known about these 2. What the problem is, what if you need to give someone partial access? You don't want them to have level 1 because they're a junior admin or they're someone who needs access to a command that's not normally found at level 1. But you don't want to give them level 15. We're going to show you how to do privilege level syntax. So how to actually move around and give certain privileges to certain levels. So let's jump right in it. First off, you can move commands around. So let's say you want the command ping to be at level 5. Well, you can say privilege exec level 5 ping. That command now is a level 5 command. Now, everything above 5 can still do ping. Anything below 5 can't ping. You then set a enable secret for that level. So enable algorithm type scrypt secret level 5 Cisco 5. So if someone types enable and puts in Cisco 5, they get any command that you have put at the level 5 privilege level. You can then go down and create a level 10, and then of course you could go to level 15 and put different, make a password for level 15. Level 15 has access to everything. You then can type enable 5, put in the Cisco 5 password, or 5 password for level 5, and when you do show privilege, you'll see your privilege level, and if you do a question mark, you will see all the commands that are available at level 5 and below. Okay. Now, there's no way to block anything below. In other words, all the commands that are normally in privilege exec mode, level 5 would have them. But you have now put ping at level 5. Level 10, same thing. Anything you put at level 10, you can do. So in this case, you've got, you put the command ping is there because it's a level 5 command, plus anything that's below that. And you put reload at level 10, so you've got the reload command. Enable 15, and you can see show privilege, and you've got everything. Basically, you are at level 15, you can do everything. So, if you're using these privilege levels, you get the privilege of any command at the level you're at or below, and there's no way to really define it in a more granular fashion. And that's the limits. So there's no limits. For instance, if you give someone the show IP route command at a level, that means they also get all the show commands and all the show IP commands. So it becomes, it's good. It's better than what we've done to this point of level 1 or level 15. But it's not as good as what we can do next, which is role-based command line access. Now, in this, we're going to create roles, and we're going to assign commands to those roles. Now, the beauty of this is you don't inherit any access from a lower role or a different role. They're called views, by the way. But you can create what are called super views. So we're going to create these views that allow us to have different privileges so that your security operator can do, you know, AAA show commands, some firewall, some IPS, some IDS, some NetFlow. And your WAN engineer can do other items. Excuse me. This is a poor man's version of what used to be Cisco's ACS server. In other words, it's Cisco ACS does this in a server-based system using Tacus and Radius, Tacus really, that allows you, or Radius, you can either one, that allows you to authorize different levels of access. But here's what we're going to do. We're going to create from the root view, okay, the root view has all privileges, okay. We're going to create these CLI views below the root view. The CLI views are roles that you create, and you assign different commands into those roles based upon what you feel that role needs, even up to and including interface commands. So what you could not do with the privilege levels. You then can also create what are called super views, and super views can contain multiple CLI views so that you can group them together. Let's say you have like a junior admin that needs views 1, 2, and 4. They can do that. Super views can also contain the same CLI view. Now, you can have up to 15 total views, CLI views. So there are some limitations, but This still gives you much more granular ability than what it does to using our previous version. Okay, it's using privilege level. Sorry, I clicked the wrong way. So we're going to do enable view and give the view a name. That's going to enter the CLI view. You also must configure AAA new model before configuring a view. So we're going to create a parser view, and we're going to give it a password so that that's the password to get into the view. And then inside of the view, we'll include commands. So we can include commands, we can add commands, include commands, we can exclude commands from a view. So here's an example of a show view. AAA new model, parser view show view. You will see that it goes into a new subconfig mode we've never seen before, which is config-view. We assign a password to get into this view, and then we put our commands. So commands exec include show. So this has the show commands in it. We can create a new view called verify view, and we include ping. Now notice it gives you an automatic error message because you've got to set the password first before you put in any of the commands. So you do secret Cisco 5, and then commands exec include ping. And then we have a reboot view. So this is very similar to what we did before using privilege levels, but we created it in views. And then when you do a show running config, you will see your views and you will see what commands are in those views. Again, there's no inheritance among these views. They're totally separate views. And then you give the users who need these the correct password, and they're able to use those views. Now, if you need a super view, do parser view, super view, and then it will give you config-view, set the password, and then you add in the super views. So in other words, you can do parser view, junior admin, super view, enable secret, and then put in these. And so this junior admin now has all three of these views and all of the commands associated with those three. If you need to verify it, you do enable view user, and it's going to prompt you for the user password. Put it in, and then you can see the commands that are available under the user that you created. And that was when they showed, where's that? I think they did user in here. Yeah, this is the user, and I'll just do show all. They created a user view. And that user has show view. So user is a super view and has the view show view. And then you can actually display what that particular user can do. And it's all, the show command, show question mark. All right. So again, show parser view shows you the view you're in. If you do enable view and don't put any name after the view, you're actually brought into root view. This allows you to do everything. Privilege level 15. Questions about that role-based CLI? That's going to show up. You're going to see that again, along with the privilege level stuff. See all, know all, hear all? Have any of you worked with this before? Any of you seen this stuff before?
No, that's new for me.
I have, Kelly. This is Sandelia. Good morning.
You've done a little bit, Sandela?
Yeah, we use it in my CCNA class now, the CCNA security class.
Okay.
It's
cool.
In the lab. Mm-hmm.
All right. Here's something that's a little different that is built into the iOS. A lot of people don't know about, but it's called the iOS Resilient Configuration Features. First off, it will actually keep a copy of the primary boot set and the running config when you enable this. So if someone happens to delete it, you can actually from ROMon get the iOS and the running config back, startup config back. It does use local storage. Okay, you don't have to worry about it going to a TFTP server. It can only be enabled and disabled through the console, so that it's very difficult if you secure your device for people to turn this off. And it is only available for systems that do have PCMCIA flash cards. So they have to have a flash interface, but of that type. If you do a secure boot image, it will take the iOS image and will create a basically hidden backup of the boot image for you. So that if someone deletes the iOS image and reboots the machine and it goes to RMon, you can still recover it from RMon. If you do secure boot config, it will do the same thing to the startup config. So if you do a show secure boot set, it will show it. And so you can walk up to a router that someone has, for whatever reason, erased the startup config and the iOS image, and you go into RMon, okay, and then you just tell it. You do dir flash 0, and you will see that boot image that has been saved by the resiliency features. You do boot flash 0, and then you can boot from that image. And then once you get into your actual running router, you can do a secure boot config restore flash 0 rescue config, and that will actually pull the iOS configuration out of the flash that has been saved by the resiliency. Good thing to turn on in real world, not necessarily a bad thing to turn on in your lab, so that you can recover when students delete the iOS image. The other thing you here do is a feature called secure copy, so you don't have to TFTP using open. You can actually go in and turn on, you have to do your domain name, generate your keys, create a login local and all, and then this allows you, this on R1, IP SCP server enable lets you actually connect to the router with secure copy protocol. And then you can copy over files to the router using secure copy instead of TFTP. So you can do copy. You can do the same thing transferring from R1 to R2. As long as you've got this, you've got to have the server on the router, IP enable. Now here's one thing I will say. Unless you're moving a large number of files between routers all the time for some reason, or you're changing configurations often, one of the things I would do with this is I would turn on secure copy what I needed, and then turn it off. And that way there's not a secure copy server running on the device using resources, and also opening up another attack surface, to be quite honest. Anytime you've got a server running on a device, that is just another attack surface that is available for a hacker. Everybody's pretty familiar with recovering passwords on a router. If you've been working with Cisco, if you've been working with students for long, you've had to do a good number of password recoveries. One thing I would tell you is make sure that you do go over this with your students so they know how to do it, because it is a big thing to be able to do this. Make sure they also know how to do it without losing the startup config, especially on a router and a switch. Because it's fine, you can blow, yeah, you can do this and erase the startup config and blow the router out and have it blank. But what if you're trying to reset after somebody just messed up a password and you want to keep your config? And Cisco does have well, that link doesn't work, but you can just go do a search for complete password recovery procedures for Cisco devices, and it will give it to you. Now, here's a dangerous little command. If you do no service password recovery, this means that you will not be able to use the password recovery features. basically that means there's no recovery. You could get in trouble, could very much get in trouble. You possibly might could get in Armon and do some things there, but more than likely what you're going to have to do is if you do this and you lose your password to the device, you are going to have to do a complete reset in some form or fashion. Maybe even wipe the flash drive and put a new iOS on the flash drive and boot it clean. So this is possible, but I would say it's better to just secure your router's physical environment so that people can't get to the router without having specialized keys or biometrics or whatever. I talked about this already a little bit, but in-band versus out-of-band management. Okay, so you're looking at, you know, out-of-band management would be managing it from a console port. Here's another way to do it. This is a terminal server that goes to console ports. Honestly, this is exactly what NetLabs is doing. There's a terminal server with an NM octal, asynchronous optical cable on it. Those octals are all going to the console ports, and it does reverse telnet. So you can go to the terminal server and then do reverse telnet. So in-band, it flows across the enterprise network. Now they're even talking about out-of-band being a dedicated management network. So out-of-band is not necessarily just the console, but it could be a dedicated management network that only management devices are on that network. Out-of-band obviously is the highest level of security, and it does mitigate risk of sniffing and anything trying to grab hold of things on your network. In-band, you know, it's only if you can't have that management network, but just make sure if you do have in-band management going across the network, if you use IPsec, you use SSL or SSH. Again, if you've got any Cisco ASAs right now, patch them, please, because there are major security holes on ASAs at this moment. Any questions about that? All right. Syslog, I'm not going to spend a ton of time here, but this is basically you've got Syslog. You've got a router and switch sending their messages to a Syslog server, basically just setting up a login host. You can go in and everything you do can be logged depending on what login level you've set. You can log to a buffer, which is the router memory. You can log to a console. You can log to a terminal line if you want to, and then to a Syslog server. Here are different levels. You do need to know these levels. It does show up on occasion. You know, level 7 basically logs everything. 6 is informational messages, like when you do a configuration. And it's, by the way, when you look at messages as they're logged, they do give you their logging level. Let's see, that one didn't. Yep, there it is. 3, 5, those are the log levels. Okay, so when you actually look, that looks here at these. Hold on one second, folks. Hold on one second, folks. So these different levels you see here, and you can set up different, it talks about you need to look at these things that are going on. There's your level, severity, okay? So this tells you exactly what level it is. So severity is 5, or 5 would be a notice, non-air condition. Your login level will depend on your environment, okay? So it really depends on what your environment's going to be and what you want to do. You're going to set up Syslog servers and clients. The Syslog, one thing I will tell you this, I always tell students that if you can't ping the Syslog server from your client, more than likely you're not going to be able to send Syslog messages to it. So verify you have connectivity to that host before you try to start doing Syslog. Otherwise, you can get very frustrated. So you do login host and then do the IP address of the Syslog server. No problem there. Then login trap level, and this is where you set your level from 0 to 7. Okay. You actually give it a new name. You can also say login source if you want it to be the a certain interface that is your login source. This may be what you want to do if you want to set ACLs on a screening router for your Syslog server to only allow certain IP addresses into the Syslog server. And then logging on, which enables logging. So here's our example here, our log host, our client. And we do login host 10222, login trap informational, login source gig01, logging on. And at that time when we do show logging, we will see that we should be sending messages to the Syslog server. Syslog's pretty simple. One thing I will tell you about the UDP port 514, that's the port that Syslog runs on. I've seen issues where a machine has already has a Syslog server running on it. You try to start another one and it fails. I've also seen, for some reason, port 514 being held by another application and shouldn't be. So just be aware that it is UDP 514. All right, I'm going to stop here. We've got SNMP, but I'm going to stop right here for today, and I will stop sharing. Are there any questions? Again, please be aware of the fact that the labs are very long. You will not be able to do a lab in an hour. Make sure when you go to do the lab for Chapter 2 that you give yourself a 4-hour block in your reservation for net labs. It is a very long lab. You do have uploads for all the labs inside of the modules in the class. So you can upload those and you will be able to jump in there. And I know this, actually we've got, 5 of you today. This may be a better time for us to start meeting than our afternoon time. I'm trying an afternoon time again next week. And then everyone kind of let me know if this is better for the class and I can get more folks here at this time. I'll do this time on Thursdays instead of trying to do yours late. So we'll just kind of play that by ear.
Okay.
All right, I'm going to stop the recording.
All right.